Okay, good morning class. So at this point you guys were given out of chapter 4 equations and inequalities, you had to do 4.1 for homework, not so. So what I'm going to do is, before I go into 4.1, I'm going to explain the examples, okay? And then we're going to look at what you had issues with, okay? So I'm reading on page 71. We are told, after completing this chapter, you should be able to solve linear equations using various methods. Okay? Then we are told literal equations, changing the subject of the formula. For those of you studying physics, it's a very useful technique to be able to use. Quadratic equations by factorization. Okay, that's a sore point to you guys. It's going to come in again. You trinomial factorization. Okay, so if you haven't mastered this yet, please take it upon yourself to go learn it, because there's going to count marks in this section of work as well. Okay. Simultaneous equations. We did simultaneous equations last year. Not so. One that has one unknown, one equation, and the other one has two unknowns, an x and a y, and the one had the x only. Here we're going to have two equations with two unknowns. Okay, I'll show you how to do that as well. Linear inequalities. What does linear mean? The highest exponent on x is 1, on the unknown is 1. And then representing the solution on the number line. One of the important uses of algebra is to solve equations. Alright. Some equations can be solved just by looking at them. We call this solving by inspection. We've done that before. If you've got x plus 3 is equal to 7, we know x is equal to 4. Just by looking at it, we can see the solution is 4. Okay, and that is known as inspection. Then, we are told that it's useful to think of an equation as being a balance, like a set of scales with equal masses in each span. For the scale to balance, okay, if you have a kilo on the side of the scale, there must be a kilo on that side as well, to keep the equation, to keep the scale balanced. Okay. If, however, you got 100 and 1 kilo, I said, no? We have 1.1 kilo on one side and you have 1 kilo on the other side. Of course, the equation is not going to be balanced. It's going to tip into the side that has 1.1 kilos. Okay, so to keep that equation balanced, we must have equal amount on either side. Then we are told when solving an equation, we must maintain the balance, so that whatever we do on the one side of the equation, we must do exactly the same on the other side. Alright, so we have dealt with equations before in grade 8 and 9. Okay, linear equations. We are told the linear equation, the highest power on the variable is 1. The linear equation in one variable or unknown can be written in the form of ax plus b equals 0. Alright, the example of those are given there. Example A is 3x minus 9 is equal to 0, and the B, 3 into x minus 1 is equal to negative into x minus 5. Then we are given the steps of solving the equation in one unknown. We are told to collect all the terms containing variables on one side, and numbers on the other side. Keep the equation balanced by doing the same operation on either side, and try and isolate the variable. Isolate means to say get the variable on its own. Alright, so I'm looking at example 1 on page 72. Example 1 on page 72. As I know, it's fairly simple. Example 1, page 72. We are told solve for x. So what's the first thing we need to do? Multiply. Get rid of the brackets. Not so. So we are told here, according to them, the first thing is collect all the terms containing the variables on one side of the equation and the remaining terms on the other side, or the constant terms on the other side. Okay. So in pursuit of doing that, what do I need to do first? What do I need to do first? Multiply, get rid of the brackets. Not so. What time of the day we need to do this? Okay. We multiply the negative 2 in. So what are we going to get? 5 minus 15x minus 20 plus 2x is equal to negative 10x. So what we're going to do is we're going to get the x's one side with the terms with the variables on the one side and the constants on the other side. So what we're going to do is we're going to take 5, negative 20, and we're going to bring negative 10x over. Not so. So that's going to give you negative 15x plus 2x plus 10x. Remember, when I bring up negative over the equal sign, it becomes positive. Then we're going to take 5 over, becomes negative 5, minus 20 becomes plus 3. You all okay with that? Any confusion? Negative 15x plus 2x is negative 13x. Negative 13x plus 10x is negative 3x equals negative 5 plus 20 is 15. Not so? So how do I get x on its own? Divide by negative 3 both sides. That cancels. So x equal to positive divided by negative is negative. 15 divided by 3 is 5. And we can test it. Wherever we see an x, we put a negative 5. So let's go with the left hand side. The left hand side. The left hand side of what? Of the equal side. It's going to be 5 into 1 minus negative 3 minus 5 minus 2 into 10 minus 5. That's going to give you 5 into. That's going to give you 1 plus 15 minus 2 into 10 plus 15. Not 10 plus 5. So that's going to give you 5 times 16 minus 2 times 15. That is negative 30. What is 5 times 16? Sorry? Sorry? 80. We give you an answer of 50. So the left hand side is 50. We're looking at the right hand side. The right hand side is going to be negative 10 into negative 5, which is also 50. So what do you notice? The left hand side is equal to the right hand side. If you had chosen any other value, let's choose 0. Put 0 in here. It's going to get you 5 into 1 minus 2 into 10, which is 5 minus 20, which is negative 15. Put 0 in here and we get 0. Is that the same? No. So that wouldn't have been a solution. You guys understand? So here you can see the equation is what we call balanced. It works. Both sides of the equal sign has the same value. But you guys understand? Do we have to test every solution we get? No. But it will be nice in case you think you are wrong, and that is how you can actually test if you're correct. Do you guys understand? Okay, this is the negative 5 is called a solution or a root of this equation. Okay. Let's look at the next one. The next example here on page 72. Example 2, page 72. We are told that if solve for x if possible. So what do we do first? What do we do first? Multiply out, get rid of the brackets. Not so. So that is going to give us negative 3x. Negative 3 times negative 1, positive 3 is equal to 3 times 4, 12. 3 times negative 3x, negative 3x minus 9. So what do I do now? X is one side, now is the other side. So we take negative 3x over and we bring 3 to the right hand side. So we got negative 3x plus 3x equals. Whatever stays here we write down first. You get 12 minus 9. Remember, if it stays on the right hand side, the sign does not change. You all okay with that? You bring positive 3 over, becomes negative 3. So what is minus 3x plus 3x? 0. Not so. Equals. What is 12 minus 9? 3 minus 3? 0. So 0 is equal to 0. Not so. This is what we call an identity. Okay, it's an identity. And when we get an identity, we write the following. All true values of x. What does that mean to say? That means to say that any value you choose of the real number set will work for this solution. You can say it's all true values for x, or we can write x is an element of all the real numbers. And what does that actually mean? You guys give me a value for x. 0, nice. So if x is equal to 0, let's go with the left hand side of the equal sign. I'm going with the original sign, okay? That being the left hand side, that being the right hand side. So you get negative 3 into 0 minus 1, which basically gives us negative 3 times negative 1, which is 3. Let's go with the right hand side. The right hand side is going to be 3 into 4 minus 0 minus 9. 4 minus 0 is 4. 3 times 4 is 12. 12 minus 9 is 3, which is equal to the left hand side. You see that, people? Choose another value. 7. Okay. If x is equal to 7. X is equal to 7. The left hand side. It's going to be negative 3 into 7 minus 1, which is negative 3 into 6, which is negative 18. Let's go with the right hand side. It's going to be 3 into 4 minus 7 minus 9. So it's 3 into negative 3 minus 9, which is negative 9 minus 9, negative 18. Good. Choose another value. Negative 1. Good. If x is equal to negative 1. So you get negative, firstly the left hand side, into negative 1 minus 1, which is negative 3 into negative 2, which is 6. The right hand side, it's going to be 3 into 4 minus negative 1 minus 9. It's 3 into 4 plus 1 minus 9. It's 3 into 5 minus 9. 15 minus 9. Which is equal to the left hand side. So any value you choose for x is going to work. As long as it's a real value. No? That's why we say all true values for x. Or x is an element of any real value. Or x is an element of the real numbers. Okay. And this is what we call this, and what do we call this? Identity. Alright. Let's go to the next one. This is example 3 on page 73. 3. Example 3, page 73. Okay. Again, the question says solve for x if possible. So what do I do here? As I did before. Get rid of the brackets, multiply out. So that gives us 5x minus 10 minus 2x minus 2 equals 3x minus 15. Now what do we do? X is one side, numbers are the other side. So 3x is going over, whilst negative 10 and negative 2 goes in that direction. Whatever stays on the left hand side we write down first. So it's going to be 5x minus 2x. We bring 3x over, becomes negative 3x. Remember the sign changes. We taking positive over the equal sign becomes negative, and negative over the equal sign becomes positive. Negative 15 is staying there, we write that down first. Negative 10x becomes plus 10x, negative 10 becomes plus 10, minus 2 becomes plus 2. So this becomes 0, not so, 0x equals negative 15 plus 10 is 5. In the negative, minus 3 is your answer. Okay, what do you notice here? Remember the previous one was 0 is equal to 0. Or we could have had 5 is equal to 5, 3 is equal to 3, or 12 is equal to 12, negative 1 is equal to... If that is the case, any value for x will work. All true solutions. However, this one here we have 0 is equal to a number. Can 0 be the same as 1? Can 0 be the same as 12? Can 0 be the same as negative 3? So that can never be. So there's no solution on this question. Okay. Or x is not an element of the real numbers. Either one of that is going to get you a mark. Do I have to state this in these sums, in this equation? Yes, this bears a mark. If you say that, one of that. Or in the previous one where you say x is an element of real numbers, or the value I said earlier on, which was all true values for x, is going to be both corrected. So what does that actually mean to us? What does that actually mean? As we did before, I chose values, or you chose values for me, no? Yes? Let's choose a value for x here and see what happens. Choose a value. 0, nice. So we say let x equal to 0. Let's see what happens to the right hand side. So it's going to be 5 into 0 minus 2. Minus 2 into 0 plus 1. So that's going to give you 5 times negative 2 minus 2 into 1. It's negative 10 minus 2, which is negative 12. Just look at the left hand side. We have 3 into 0 minus 5. Gives you 3 into minus 5. Is the left hand side equal to the right hand side? No, which confirms there's no solution. Which value of x you think it could have been? Let's go with minus 3. Let's see what happens if it's minus 3. Will the left hand side be equal to the right hand side? Let's check. If x is equal to negative 3, I was. Morning.
We're going to be 4 minutes at the out.
No problem. Boy.
Morning.
Okay, so if x is negative 3, on your left hand side, what would you have? Left hand side of the equal sign. What do we have? 5 into negative 3 minus 2, negative 2 into negative 3 plus 1. Not so? Which is now going to give us 5 into negative 5 minus 2 into negative 2. Okay, so we multiply. What is 5 times negative 5? Negative 25. Negative 2 times negative 2? Positive. Which is negative 21. The right hand side of the equal sign is going to be 3 into negative 3 minus 5. What's negative 3 minus 5? Positive 15. Negative 5 negative minus 3. Negative 8, which is negative 24. Is the left hand side equal to the right hand side? No. Which confirms no solution. So you can choose any value for x. It will never work. Okay? You guys understand? Pleasure. Yes. Okay. Okay, so then you guys had exercise 4.1, correct? In exercise 4.1, so at this point, you can pause the video and then do 4.1. Okay. But at this point, the learners has done 4.1 already. So, any problems with 4.1 in number 1? Sorry? Yes, Michael? Okay. Exercise 4.1K. Anything else? Just hang on. Exercise 4.1. This one page? Sorry? 73. And number 1. Okay, what's the other one? J? G. Anything else? H and I. Okay, that's enough. Okay. Who asked for K? Right, go for it. What did you read for me? What do you have in your book? You wrote this up twice, no problem. Carry on. Yeah. Huh? When you multiply this out, what did you get? Yes. 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 Yeah. Carry on. Yeah. Yeah. Yes. Carry on. Equals. Carry on. Huh? What are you going to do now? Add like terms. It's gone. What is x plus 2x? 4x minus 3x? X. Minus 0. So x equal to negative 0. G? Who asked for G? Go for it. No, it doesn't matter if you show your mistake. Let us see what your mistake is. Carry on. Say again. The other 7 is a Z. What's wrong with you? Z. Oh, you say Z. Okay. Equals? Yeah. 3 into negative 2. Go again. 3. Negative 2 here. C plus 2. Okay, carry on. Nice. You just brought that to the front. This here. Okay, so you've got z squared. So you've got 5 minus z is equal to 3. That is going to give you positive 2 into z plus 2. That's all? Just get rid of the brackets. So 5 minus z is equal to 3 plus 2z plus 4. Bring that over, that on that side. We've got negative z minus 2z is equal to 3 plus 4 minus 3 plus 4 is 7 minus 5 is 2. It's negative 3z. Divide by negative 3 both sides, z is then equal to negative 2. Is that correct? Sorry? Right? Who else made a mistake on the sum? Nobody else. Okay? We're looking at h. So what do we do first? What are the brackets? Multiply. Nothing is binding that bracket. Okay. Who asked this question? Right, go for it. Three x, yes? 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 Equals? X minus 2 minus 3. Is that what you wrote? You actually multiplied the negative 3 in. Yeah. That's why I mentioned at the beginning on the offset. That bracket has nothing binding that bracket in. Monimus? You all see that, people? Unless here was a times here or this was in a bracket, then I would multiply that. But in this case, he didn't have that. You understand? So, since there's nothing binding that bracket, I can drop the brackets at this point. Of course, x is one side, numbers the other side. So it's going to be 3x minus 4x. Minus x is equal to minus 2 minus 3 plus 3. That's going to give us 3x minus 4x negative x minus x negative 2x minus 5 plus 3 is negative 2. So x is equal to 1. You all agree with that? Is that correct? Right. You guys may make sure that I'm right, no? So I'm not always correct. I'm not as good as you guys, no? You guys are better than me. I only beat you on one thing, which is trinomials. Sorry? You feel traumatized? Good. What are you doing about it? Sleeping early. What are you doing about it? You watching the video? I will see if you watch it in the next exam. Okay. People, I. Who asked for I? Who am I? Right, go for it. 8x, yes? Minus 40, yes? Yes? Yeah? 10? Minus 8x? Nice! Right, carry on. 8x minus 2x? Good, equals? Minus 6. Huh? You wrote minus. Okay, good. Oops. Next. That 16 is 14 is absolutely correct. 56. 12, 6, 50 is absolutely correct. Over 14. So x equal to 4. Where did you go wrong? You got 56 over 14. Did you know you can use a calculator? That's the problem. What's wrong? Yeah, you don't use a calculator in your exams, you don't use a calculator in the class there. What's wrong with you? But still you get the highest mark. Nice, nice. Do you know how to factorize a trinomial? Okay. Shall. Right, let's go back to the drawing board. Any other problems with number 1? No. Let's go to number 2. Where's the Mickey Mouse happening in number 2? Oh, number 2 is to do with I, J, K and L. None of those questions was asked. What's wrong? I'm going to the third one now. Module 3. Which is what? Numbers. Pattern. That we leave for the you that you can do on your. You can study that topic on your own. That was easy. Okay, he's asking about number patterns. No, Mickey Mouse work, man. Mickey Mouse. And that's why you want to do it. It's easy. We are going to do it, man. Probably in term 3 or 2. The other. But this is more exciting than that, isn't it? Yeah. You don't, then. Sorry? It's geometry. Oh, are you going to start geometry soon? After this. Right, so, just remember now who said they like geometry. Geometry is also my favorite. After trigonometry and algebra and probability and. Sorry. Okay, sorry about that. Number 3 people, any issues here? B. D. Huh? B. Oh, D. Okay, I got it. How much I know? D. Hier gaat ons. Anything else? Enige iets anderstig. Is that right? Yeah. One day I'm going to take my wife out. I'm going to speak only Afrikaans. She's good at Afrikaans. I'm going to be Afrikaans praat op die. Wat is het date in Afrikaans? Huh? Datum? Nee man. En gaan jou uitvat op 'n datum. 'n date. Ja. Romantiese aand. Hey, jy gaan 'n bietjie te ver. You can have a date in the afternoon. What's wrong with you? Okay. I'm going to tell you. You must learn. You have an Afrikaans teacher? What is the right word for date? You can tell me, no? People, sorry, this is the only problem in this one, 3D, no? Okay. So when we start, who asked this question? Right, go for it. Yeah? You multiply the first and the last. You all agree with that? If the conjugate pair, it results in the difference of two squares. Is that what you wrote? What is wrong with that, people? Must be in a bracket, yes. Why? Why must it be in a bracket? Yeah, more than one term following a negative sign? Put in a bracket. Okay. The negative must be multiplied. 5 minus y squared equals 1 minus y squared minus plus 4. Y is one side, number is the other side. So minus y squared plus y squared equals 1 plus 4 minus 5. Which is negative y squared plus y squared? 0. So 0 is equal to 0. What is this? An identity. So x is an element of the reals, all the real numbers. Alright. People, you guys understand? Verstaan julle? Alright, so at this point we're going to now look at equations with fractions. There's your next heading. Equations with fractions. And here's the notes I want you guys to write down. Equations with fractions. In deze op bladzij 74. Onze kilo 1, ne? Is that right? Wie zit go with the let's sit here in front. You went to the other maths class? Oh, she missed a maths class for. No, I don't like this. Who else is missing the maths lesson? So if she was here, she would have also gone on the interact excursion. How can you miss maths? What's wrong with you? I would have never missed maths. Ever. I'll tell you a story when I pause this video later, okay? About missing maths. Okay. Right, equation with fractions. I want you guys to write the following steps down. To solve an equation that has a fraction in it. Start by transforming the equation into one without fractions. Steps to solve the equations that has fractions in it. You write this down here. These are your steps, okay? Steps on. Step 1. Find the lowest common multiple or lowest common denominator. LCD. Number 2. Multiply both sides by the LCD. And number 3. Solve the resulting equation. Alright, write that down quickly. Yes, today is a shorter lesson. I was thinking now, we are finishing at 11:30. In actual fact, we're not, so we must move. Otherwise, you're not going to have homework. Then you will think there's something wrong with me. Schrijf je. Okay. So we're looking at example 1 on page 74. Example 1, page 70. So here we are told solve for y. If 10y minus 1 over 2 is equal to 4 into 7y plus 1 over 5 minus 1. Okay. So what's the first thing we need to do? The first step. LCD. What is my LCD here? LCD. Yes? Okay. What's the next step that it says? Multiply both sides with the LCD. So I multiply this whole thing here by 10. So it's 10 times 10y minus 1 over 2. It's going to be 4 into 7y plus 1 over 5 minus 1 times 10. Okay, you all agree with that? Which could also be written as, you can multiply each fraction or each term, sorry, by 10. Okay. This must 10 over 1, eh? 1 over 1, so. You all agree with that? So write that down quickly. So what happens here? We can 2 goes into 2 once, 2 goes into 10, 5 times. So it's 5 into 10y minus 1. You all agree with that? Equals. In the second fraction, what can happen here? 5. 5 goes into 5 once, 5 goes into 10 twice. And that 2 times 4 is what? 8. So it's 8 into 7y plus 1. Minus, can anything cancel here? No? So it's just here. So what does that now become? Exactly what we're familiar with. It's been an equation from the beginning. Becomes an equation as we did in 4.1. Not so? So do your thing, multiply out. So what do we get? 5 times 10y? 51 minus 5 equals 56y plus 8 minus 10. So what do I do now? Y is one side, number is other side. So do your thing. You finish. Oh, sorry. So you're getting 50y minus 56y is equal to 8 minus 10 plus 5. Negative 6y, of course, is then equal to 3. Divided by negative 6 both sides. So y is equal to negative. And if I put negative half wherever you see y, you put the equation. You all understand? Any confusion? Not yet? Faith? It's not your name. It's for your name. Okay. What's your name? Huh? JD, okay. Well, after I said Faye, I thought that was Faye. But okay. Because I was by mistake right. Okay. People, any issues here? None, huh? Okay, we'll do another one. Yay. Let's do example 2. Number 3. Solve the blood say. Here we are told in example 2 on page 74. Solve for x. We got 3 over 2x minus 4 over x equals 6 over x. X may not be equal to 0. Why do you think they're telling us that x can't be 0? Otherwise the solution to the sum will be undefined. If there's any part of the sum that comes to be undefined, it doesn't work, okay? The whole sum is undefined. So, do your thing here quickly. Guys, finish. Does that do it? Yes. So what's your LCM here? LCM. For 2 and 4 is 4. X and X is X of course. So now I've accounted for all of that. That's all. We're going to get what we call a restriction. Restriction is values for which X can never be equal to. You see this LCM, which is 4X, that can never be equal to 0. So X can never be equal to 0, which confirms what they're telling us here. Okay. So let's see what we get. The rule says you want to multiply each fraction by the LCM or LCD. So it's 4x times 3 over 2x minus 4x times 1 over 4 equals 4x times 6 over x. So what we do is this naturally over 1, over 1, over 1. Not so? So here x cancels x. 4, 2 go into 2 once, 2 go into 4 twice. 2 times 3, 6. Minus 4 cancels 4, not so? So x times 1 is x equals. That cancels. 4 times 6 is 20. You see that? So what do I do now? X is one side, number is the other side. So negative x equal to 24 minus 6. What's 24 minus 6? 18. Divide by negative 1 both sides. Therefore x equal to negative 18. Is that correct? You don't just say yes. You wrote down the sum from the board. I will say it's here, right? Negative 18 is correct. For homework, before I forget. For homework, I want you guys to do exercise 4.2. Okay? 4.2. Is this too much? No. Okay. Huh? Let me see by a show of hands who says too much. Nobody. Okay, nice. People, enjoy the rest of your day. Good morning, class. Yes? Just hang on. Yes. Without denominator is fine.